influential substance on Earth. It covers more than 70% of our planet's surface, plays a key role in weather and climate, and nurtures life itself. Earth's deep oceans are unique in the solar system, and their globe-spanning majesty, as seen from space, is a testament to the primacy of H2O. Oceans, however, are just the most eye-catching repositories of water. The substance can be found in lesser amounts in almost every nook and cranny of the planet, and researchers know it is important to keep track of water everywhere. For example, in mud. Believe it or not, NASA has just launched a satellite that can track water in the muddy slosh under your feet, as well as other forms of water in the ground. The name of the mission is SMAP, short for Soil Moisture Active Passive. The satellite left Earth on January 31st, rocketing into the sky on board a United Launch Alliance Delta II rocket from Vandenberg Air Force Base in California. There's more to soil moisture than mud, of course. With data from SMAP, scientists and decision-makers around the world will be better equipped to understand how Earth works as a system, says Christine Bonnickson, SMAP Program Executive at NASA headquarters. It will show us the down-to-earth impacts of soil moisture, from floods and drought to weather and crop yield forecasts. SMAP senses soil moisture using an extraordinary mesh antenna. A large 6-meter mesh reflector antenna will deploy like a pop-up tent and spin lasso style at approximately 14 revolutions per minute. Through this antenna, both the radar actively pinging the ground below with microwaves and the passive radiometer listening to the Earth's emissions can gauge the moisture in soils along the satellite's ground track. Circling Earth in a 426-mile altitude near-polar orbit, SMAP will be able to produce high-resolution moisture maps every 3 days. Water in the soil can exist in many forms. As it orbits, SMAP will be able to detect whether the ground within its 3-kilometer-wide footprint is frozen or thawed. This capability, which is unique to SMAP, will assist scientists in determining the growing season length and how much carbon plants are removing from the atmosphere each year, thus improving our current understanding of global warming. Additionally, SMAP will enhance our ability to respond to weather-related catastrophes by contributing to flood prediction and drought monitoring. Soils are like sponges, explains Erica Podest, a scientist on the SMAP team at NASA's Jet Propulsion Laboratory. They can hold a certain amount of water. If we know the amount of water in the soils, and we know that there's a big rainstorm coming, for example, and that the soils are near saturation, then we can predict that that area might be at risk for flooding. Clearly, mud does a lot more than just lie underfoot. The data gathered by the SMAP mission will be invaluable both within and beyond.
NASA is sending a new Earth research spacecraft into orbit to measure and map the moisture within our planet's soil. The Soil Moisture Active Passive mission will use remote sensing instruments to create global maps of Earth's soil moisture, helping us better understand water and carbon cycles. SMAP will get a boost into polar orbit aboard a United Launch Alliance Delta II rocket launching from Vandenberg Air Force Base in California. The first stage of the Delta II pulled into Building 836 on July 23, 2014. It was offloaded and moved to the horizontal processing facility at the launch site. On August 4, the first stage moved out to the mobile service tower at Space Launch Complex 2. A crane lifted the booster into the vertical position, then the interstage adapter was installed on the top. The rocket's 3 solid rocket motors were attached to the first stage on August 18, and 2 days later, the booster was topped with the second stage. Once inside Astrotech, SMAP was put through a series of inspections and tests to ensure it's ready to perform during its 3-year mission. The spacecraft wrapped up its pre-flight processing in mid-November. Final preparations began in the new year. SMAP was joined to its launch vehicle hardware on January 7, and during the following days, it was bagged in a protective cover and placed into a canister for the move to Space Launch Complex 2. The observatory was transferred to the launch complex and hoisted into place atop the Delta II rocket on January 13 and secured inside the protective payload fairing later the next week. Each of these milestones sets the stage for success as NASA sends its newest satellite on its mission to map Earth's soil moisture.
Turn your phone or tablet into a virtual time portal with a new NASA app that'll put you on the launch pad with the Space Launch System rocket looming over you. The app, called NASA 3DV, was managed out of KSC and highlights our Ground Systems Development and Operations program. The first actual combined flight, SLS and Orion, won't happen till 2018. But why wait? See how it'll look by downloading this app on iTunes right now. And Kennedy Space Center Director Bob Cabana is the recipient of this year's National Space Trophy. The award is presented annually by the Rotary National Space Foundation for major contributions to our nation's space program. And remember, Spaceport Magazine digs deeper inside KSC.